All right, tonight we're going to point our cosmic telescopes toward the constellation Gemini, because there's this incredible story of a star cluster hiding there, Messier 35. Now, if you were to look up, you might just see a faint, fuzzy patch of light. But trust me, it's so much more than that. It's like a bustling city of stars, and it's got some really fascinating secrets. So, let's dive in.
And there it is. Just look at that. This glittering spray of stars is M35. And see that little fuzzy patch to the lower left? That's its older, much more distant companion, NGC 2158. It's just a breathtaking view, and for centuries, stargazers have absolutely loved pointing their telescopes right here.
You know, for so many amateur astronomers, finding M35 is kind of like a rite of passage. There's this genuine, personal connection people feel when they finally spot it, even if it's just with a simple pair of binoculars. It's that shared feeling of discovery that makes these faraway objects feel just a little bit closer to home. But here's the thing. This serene, peaceful image, it's a little bit deceiving. If we could zoom in and fast forward through millions of years, we'd see something totally different. We'd see a dynamic, almost chaotic place. We're talking stars that pulse, stars that spin like crazy, and stars that are literally dancing with partners.
Okay, so let's get properly introduced. To really get to the bottom of its secrets, we first have to understand exactly what M35 is and where it lives in our galactic neighborhood. So M35 is what astronomers call an open star cluster. The best way to think about it is like a stellar nursery. All these stars, maybe a few thousand of them, were all born from the same gigantic cloud of gas and dust. They're basically siblings, still kind of hanging out together, loosely held by gravity as they drift through the galaxy.
But here's where it gets really tricky. To understand M35, scientists had to do something incredibly difficult. They had to take a census. They had to figure out, out of all the thousands of stars we see in that direction, which ones are the true residents and which ones are just, well, photobombing the picture.
And you can imagine, that is a huge challenge. I mean, think about it. We're looking through this massive, deep stretch of the Milky Way. You've got stars in front of the cluster, and you've got countless stars behind it. So the big question is, how on earth do you separate the real members of M35 from all that cosmic noise? Well, the first tool in the toolbox is something called proper motion. The idea is pretty simple. Since all the cluster's stars were born together, they're all moving through space together, kind of like a flock of birds. So by tracking this teeny tiny drift across our sky over many, many years, astronomers can pick out the stars that are all flying in formation. The second tool is called radial velocity. This one measures how fast a star is moving either directly toward us or away from us. And just like with proper motion, all the real members of M35 should be moving at roughly the same speed. It's another absolutely crucial piece of the puzzle. So the whole process is basically cosmic detective work. First, astronomers measure the motion of thousands and thousands of stars. Then, they calculate what's called a membership probability for every single one. And finally, they filter out all the imposters to isolate the true population of M35. And the scale of this work, it's just staggering. One major survey, and this was just focused on radial velocity, took more than 5,000 individual measurements from over 1,000 stars just in the direction of M35. It was a truly monumental effort. And after all that work, after sifting through all that data, what was the result? Get this. They confirmed 360 true cluster members. Just 360. It brilliantly shows just how meticulous this science is, right? You go from thousands of potential candidates down to just a few hundred confirmed residents. Now, that incredibly hard work really pays off. Because once we know who actually lives in M35, we can finally figure out its core identity. We can pin down its age, its mass, and exactly where it is in space. So what did this big census tell us? Well, first up, the cluster's age. It's about 150 million years old. Now that might sound ancient to us, but in cosmic terms, that's basically adolescence. This makes M35 a really important intermediate age cluster. It's also a real heavyweight. The total mass of all its stars adds up to somewhere between 1,600 and 3,200 times the mass of our own sun. That makes it one of the more massive open clusters we know of. And as for its address, well, it's about 2,970 light-years away from us, over in the constellation Gemini. That's far enough away to be a challenge for sure, but close enough for our telescopes to study it in amazing detail. Okay, so we've got the basics down, but this is where the story gets really interesting. Because once astronomers knew who the real members were, they discovered that this star city is anything but quiet.
It turns out a huge number of M35 stars are what we call variable. Their brightness actually changes over time. Some of them are physically pulsing, getting bigger and smaller. Others are spinning incredibly fast, and their star spots whip in and out of view. And some are binary systems, where one star passes in front of its partner, causing a light to dim.
And when you break it down, you find something really surprising. Of all the variable stars they found, the vast majority, 232 of them, are rotating variables. That means their brightness changes because of their spin. This whole cluster is just a whirlwind of activity.
This big discovery about all the spinning stars led to an even bigger breakthrough. It turns out there's a clear dividing line inside M35, a line that actually shows us how stars evolve over time.
What researchers found were two totally distinct groups. The first is a bunch of fast-spinning stars. Think of them as being in a more youthful, chaotic state. But the other group is this beautifully ordered sequence of slower spinners, stars that have actually put the brakes on over time. And here's the crucial part. In one single snapshot of M35, we can see stellar evolution happening right before our eyes. It's incredible. And all of this, the age, the population, the crazy dynamic stars, it all comes together to make M35 an incredibly important place for astronomers. It's not just another pretty picture in the sky, it's a perfect, natural laboratory. So why does M35 matter so much? Well, for a few key reasons. First, its age, 150 million years, perfectly bridges the gap between young clusters like the Pleiades and older ones like the Hyades, letting us connect the dots of how stars grow up. Second, that clear split between fast and slow spinners makes it the perfect place to test our theories on how stars slow down. And finally, its most massive stars are right on a critical borderline, helping us figure out the exact mass that decides if a star will end its life quietly as a white dwarf or go out with a bang in a supernova explosion. You know, M35 shows us that even a faint, fuzzy patch of light in the night sky can hold this epic story of birth, evolution, and destiny. It really makes you wonder, doesn't it? What other cosmic stories are written in the stars, just waiting for us to read them?